There is a long relationship between maps and flags, and they're often printed on the same page. The canvas proportions are based on common flag ratios, forming an initial link between maps, software, bias, and ideology. It is only within the last few hundred years that north has been consistently at the top of maps. Early Chinese compasses were oriented to point south, leading to maps with south at the top of the page. This orientation was switched to north-facing up maps by an emperor living in the north of the country who wanted to place others in a position of subjection, looking up to his power. Up, like many other aspects of maps, is a human construct based on power, history, and bias rather than anything to do with nature. Mapping projections are ways of taking a spherical set of data like the globe and collapsing it to a flattened image that can be printed on a page or rendered to a screen. Perfectly flattening the three-dimensional globe into a two-dimensional image is an impossible proposition that always leads to distortions in proportion and scale. These distortions, intentionally or unintentionally, are influenced by the biases of the mapmaker. Notions of center, scale, up, and down influence the way the world is communicated to us through maps, and influences the way we see the world. Worlds and Figures contains 121 different mapping projections ranging from the year 150 AD to 2018. Removing the clipping constraints allows these projection algorithms to extend beyond the bounds of the map or edge of the page. Mapping projections can be applied to any image by dragging it into the main window. The color palette consists of 12 colors defined by the Telecommunications Industry Association's TIA 598C Optical Fiber Cable Color Coding Chart. Cutting through the black outer layer of a fiber optic internet cable reveals 12 specifically colored inner cables. And inside of each of those colored cables is the repeated 12 colored cables, all containing a single strand of glass thinner than a human hair. Through a combination of the outer color and inner color, each of the 144 fiber optic strands is assigned a specific number. And just as flags have a relationship to maps and ideology, so do networks. Our current network of buried glass strands did not descend from the cloud, but rather has a history dating back at least as far as the Empire Girdle, otherwise known as the All Red Line. This was the name given to the first telegraph network to circumnavigate the globe, which landed only in areas shaded red on maps depicting the British Empire. Cartographers have developed different systems for communicating the relationship between map projections and distortion. The graticule, or grid lines of parallels and meridians, are almost as old as the concept of the spherical Earth, and are detailed in Ptolemy's geography circa 150 AD. Tissot indicatrices, or ellipses of distortion, were developed by the French mathematician Nicolas Auguste Tissot in 1859 to illustrate and characterize distortions due to map projection. In 1910, Edward Ayerst Reeves, the map curator of the Royal Geographical Society in London, taught courses in surveying and practical astronomy for explorers, missionaries, army officers, and colonial officials. In his lectures, he began using the profile of a human face rather than the continent outlines, stating that there are those of us who can more readily appreciate what the shape of the average man's head is than they can the general form of the land masses of Earth. The idea gained momentum, possibly due to the fact that human brains are evolutionarily hardwired to recognize faces. While Reeves employed a single profile of a face that stretched nearly from pole to pole, in 1946, the Russian cartographer Andrei Vochekovich-Gedemin inscribed the face twice, once in the southern hemisphere and once in the northern. This technique for visualizing mapping distortions has continued popularity in contemporary cartographic circles and has been extended to software-based implementations. In addition to its educational uses, there is perhaps also something poetic in Reeves's gesture, in the implied suggestion that in order to see how the world bends, we must first see ourselves. However, if we look to these profiles, ourselves is defined quite narrowly, and this lens with which we use to look for distortions is itself distorted with bias. Worlds and figures allows us to create our own personalized, geocoded profiles of the ones we know the most intimately, the ones for which we will notice even the slightest bend in any curve. Just as maps are more like narratives than they are like rulers, so is the software we make and the software we use on a daily basis. These systems are narratives similarly bent intentionally and unintentionally by the histories and biases of those with the power to define which way is up.